Hey there. Okay, so when dividing fractions, the trick is to take the reciprocal of the second number and then multiply. So a way of thinking of that is if you think about 10 divided by 2, for instance, we know that's 5. I can also think of that as 10 times the reciprocal of 2, which would be 1 over 2, because remember there's a little invisible 1 down there. So we're essentially flipping the second fraction and then rewriting it as multiplication. And then 10 times 1 would be 10 over 2, and it comes out 5, which we know that 10 divided by 2 is really 5. And so it works for whole numbers, and with fractions it makes it much easier because multiplying fractions is actually not too terrible. So 5 6, so instead of having this as a division, we're going to rewrite that as a times, and then take the reciprocal of the second number just like I did over here. And then from here, there's a couple of things you can do. You can just multiply straight across. So 5 times 3 would be 15, and 6 times 1 would be 6. But when you do that, then you have to be careful that you have the most reduced form of this fraction. And so if there is a common factor in the numerator and denominator, I can cancel that out and reduce the fraction. So if I think of what 15 would factor to, it would be a 3 times a 5. If I think of what 6 would factor to, it's a 3 times a 2. And so then right there I have 3 over 3, which reduces, and that gets you that 5 halves that you mentioned. A little bit slicker way to do this is instead of just multiplying straight across, is if you can see that you can reduce before you multiply, reduce that. So for instance here, 3 goes into 3 once, 3 goes into 6 2 times. And then when you multiply 5 times 1, that's 5. 2 times 1, that's 2. So it's actually easier if you can spot the reducing. It's actually easier just to spot the reducing before you multiply. Let me do one quick example of a case where that would be, it would make it much easier. So let's say we had 25 over, let's go 18 times 9 over, let's do 10. So if I multiply that across, what would that be? 25 times 9 would be 225 over 180, and I would get really big numbers, and that would be kind of hard to reduce. But if I can look here and go, oh, 25 and 10, those both have 5s in common. So 5 goes into 10 twice, and 5 goes into 25 5 times. Cool, got that out of the way. And then the 9 and the 18, I can say 9 goes into 9 once, 9 goes into 18 twice, and then I multiply straight across. 5 times 1 is 5, 2 times 2 is 4. I suffered a lot less than if I'd gone down the 225 over 180 and then tried to get that reduced with those big numbers. So to recap, anytime you have a division problem with a fraction, just take the reciprocal of the second number and rewrite it as a multiplication. And then again, it's easier generally to spot what you can reduce before you actually multiply. Hopefully that helps. Holler if you still have questions.